last one, I made a little mistake. I forgot to set it equal to 0, so start with that. And then let's go ahead and think about solving it. So, on this one, we're going to go ahead and I would use what you know. So like, let's rewrite tangent in terms of cosine. So if I do that, I get sine and cosine. So tangent is sine of 2x over cosine of 2x minus 2 cosine of x equals 0. Okay, we know that sine of 2x is 2 sine of x cosine of x. And we know that cosine of 2x is cosine squared x minus sine squared x. And we're still subtracting 2 cosine of x. The problem is I usually want to make this one fraction to solve. So I'm going to multiply both this by cosine squared x minus sine squared x on the top and bottom such that they will have a common denominator. Okay, still equals 0. So as I look at the top, I get 2 sine x cosine x minus 2 cosine cubed x plus 2 sine squared x cosine x all over cosine squared x minus sine squared x equals 0. Okay. As you look at the top, when you're saying something equal to 0, we really only need the top to equal 0. So I can just focus on this top part and factoring it and setting it equal to 0. So let's go ahead and let's move over here. As we think about factoring that, I'm going to leave the first part alone, 2 sine x cosine x. But I'm going to take out, I noticed that I could take out like a negative 2 cosine x from both of these. And I'm left with a cosine squared x minus sine squared x. Okay. We know that that is equal to, actually, let's take that back for a second. Yeah, we can do that. Okay, so I get 2 sine x cosine x minus 2 cosine x times, that's equivalent to cosine of 2x, right? Okay, so that's fine. So now let's look at both of those. It's still equal to 0. And let's take out our GCF. So both of these have a 2 cosine of x. So I'm left with sine of x minus cosine of 2x in the parentheses equals 0. So now I want to think about both of these. This first one, 2 cosine of x equaling 0, is just really saying when does cosine of x equal 0. So we get that x is 0 whenever we're at pi halves, and then every pi k that will repeat. Okay, let's go to the next one though. This one's a little trickier. Sine of x minus cosine of 2x equals 0. That has 2 different trig functions. So ideally we want to make it into the same trig function. So let's go back over here to the right and remind ourselves when we've got cosine of 2x, there's one other equivalent form, and that's 1 minus 2 sine squared of x. If I replace that in my equation, I'd be left with sine of x minus 1, and then subtracting a negative 2 would be adding, plus positive 2 sine squared of x equals 0. Just to help you see this, I would rewrite it as 2 sine squared of x plus sine of x minus 1 equals 0. And then think about factoring. I'm going to let you take a moment to factor it, and then hit pause and then hit go again when you're ready. And you should end up with sine of x plus 1 times 2 sine of x minus 1 equals 0. So when does sine of x plus 1 equal 0? It's when sine of x equals negative 1, which happens when x is 3 pi halves plus 2 pi k. However, notice we already had pi halves plus 2 pi, so that will be incorporated in the other answer we already got. So now let's look at this one. When 2 sine x minus 1 equals 0, that's saying when does sine of x equal a half? And we end up getting that at 2 different places. We get that when x is equal to pi sixths, but it's also positive in the second quadrant, so pi 6 less than pi is 5 pi sixths. And then we're adding our 2 pi k. Okay, that one was definitely a bit of a doozy. So we have, see here, we got these different answers, and if we wanted the exact solutions in that interval, we'd have pi halves, 3 pi halves, pi sixths, and 5 pi sixths. There are 4 different solutions in that 2 interval. Okay, pause it for a moment. All right, to pick up where we left off, we now have just 3 examples. That is, you're going to have to make some decisions about how to best solve them. So in this first one, we've got cosine of 2x, cosine of x, sine of 2x, sine of x equals 1. So we've got 2 different trig functions, 2 different arguments. So it'd be super nice if we could combine these. I'll give you the hint here. On these ones, I would think about, what do you recognize? You should recognize something about cosine, cosine, sine, sine. This is the equation for the difference angle formula for cosine. So this is equivalent to cosine of 2x minus x, right? Equals 1. So now if I simplify that, I get cosine of x equals 1. So we're saying, hey, when is cosine equal to 1? Oops, or you could say, what's arcsine of 1? And we end up with x being 1 at 0. And that happens every 2 pi k. So this would be your exact answer, right? Incorporates everything. And then on that interval, you would have just x equals 0. Okay, on this next one, I'll tell you that there's a formula that you kind of want to that you'd want to use. So I'll write it over here because I kind of told you that you didn't have to know this one offhand, but I'd give it to you. But sine of alpha, plus sine of beta equals 2 sine of alpha plus beta divided by 2, and then cosine alpha minus beta divided by 2. Okay, so let's use that in this case. So we're going to have 2 sine, our alpha is 6x, plus our beta is x divided by 2, times cosine of alpha is 6x minus beta of x divided by 2 equals 0. So we get 2 sine of 7x divided by 2, cosine of 5x divided by 2. Since this is equal to 0, think about, hey, how do you solve something like this? Well, you set each of them individually. I mean, we could think about dividing by 2. That's not going to make a difference. That would just make this disappear. 0 divided by 2 is still 0. But either this first factor or this second factor has to equal 0, and then my equation would also equal 0. So if we think about this first one, when does sine of 7x divided by 2 equal 0? Well, so when does sine equal to 0? Sine is equal to 0 when x is 0 plus every pi k. But in this case, our x is 7x divided by 2. So if we wanted to get x all alone, let's multiply by the reciprocal. Oops, sorry. So 2 over 7. So we get that x is 2 pi k over 7. Similarly, I could do the same thing over here. We're saying, when is cosine of 5x divided by 2 equal to 0? That's true, in this case, for our 5x divided by 2, when x is pi halves plus every pi k. So think about multiplying by the reciprocal. Oops. I did not multiply by the reciprocal. The reciprocal is 2/5, not 5/2. Gotta actually flip that. So pi halves times 2/5, the 2's would cancel, so I'd be left with pi fifths plus 2 pi k over 5. Okay, so those are our exact solutions. And then we've got, in our interval, 0 to 2 pi halves, 0 to 2 pi. On this first one, when I plug it in, I get 0. I get 2 pi sevenths. And then I have like 4 pi sevenths as you keep multiplying, all the way up to 12 pi sevenths. And then on this next one, we start at pi fifths, and then I'd add another 2, so I get 3 pi fifths. I get 5 pi fifths, or pi, right? All the way up to 9 pi fifths. Okay, one last one. These tangent ones are kind of a doozy, I'm going to warn you right now. So, on this last one, I started just writing things in terms of what I knew, so sine and cosine. So, as we look at this, on the left we'd have, and I will say I played around with it a little bit, like using the trig identity of like 1 minus sine squared and stuff too, and I didn't see that it was like any easier, so therefore I just went back to rewriting it in terms of sine and cosine. Also, it does not factor. So, on this left side, we're going to have 2 of sine of x over cosine of x. On this right side, I'm going to have 1 minus sine squared x over cosine squared x. So, I want everything to have a common denominator, so I'm going to make everything in terms of cosine squared. To have this one be over cosine squared, I'm going to multiply the top and bottom by cosine x. And then the 1, so I'll rewrite the left actually, 2 sine of x, cosine of x, over cosine squared of x, and then 1 will be cosine squared of x over cosine squared of x, minus sine squared of x over cosine squared of x. So, this 2 cosine x, sine x, cosine x, you should recognize as sine of 2x, right, all over cosine squared of x. And then on this right side, if you have the cosine squared of x minus sine squared of x, you may recognize that, or you should recognize that of cosine of 2x over cosine squared of x. Okay, we notice they have the common denominator, so we could just say, okay, well, let's get rid of the denominator, let's multiply both of them. But really what it's saying is that the tops are equal. So, now I've got 2 different trig functions, same input though. So ideally we'd want it as 1. Sine and cosine do have a relationship though. So if I divided both sides by cosine of x, you should recognize this left side to be tangent of 2x. And we have that it equals 1. This is something we know how to handle, right? So when is tangent equal to 1? Well, that's true when we have, it's 2x equals pi fourths. And it repeats every pi k. To get x all alone, we divide by 2. So x equals pi eighths plus pi k halves. So that's your exact answer. And if you wanted to think about all the ones that work in that interval, we'd start at x equals pi eighths. And I probably think about pi k halves as being like 4 eighths k. So we're basically adding 4. So 1 plus 4 is equal to 5. So 5 pi and eighths. Add another 4 and we get 9 pi eighths. Add another 4, we get 13 pi eighths. And if I add another 4, I'm all the way to 17, and that's too high.